Hi, welcome back. The past few days we've talked about 11.5 and 11.6. So this is a recap video on 11.5 and 11.6. Okay, so let's talk about 11.5. So 11.5 was talked about inscribed angles and circumscribed figures. Okay, so what we found out about inscribed was inscribed means inside, circumscribed is outside. Okay, so in inscribed angles, okay, so we had a formula for an inscribed angle, and that formula was the angle equals half of that arc, whatever that arc may be. Okay, so again, arcs are created by two chords. Okay, in inscribed angles, not necessarily go through the center of the circle. So this little dot in the middle is that center of the circle. I have my circle around it. Okay, so let's try an example. So an inscribed angle, so I'm going to draw some chords. Your inscribed angle could be something like this. Okay, if I had my arc, so again, my arc is, oops, let's go a little bigger. My arc is this piece here. Let's say that was 140. If I'm given that that's 140 degrees, I want to find what this part is here. I want to find that inscribed angle. It's an inscribed angle because it is inside of my circle. Okay, so my angle using this formula equals half of my arc. My arc is 140. Okay, well, half of 140 is 70 degrees. So my angle down here instead of x, that's actually 70 degrees. Okay, let's try it the other way. So let's say I am given my inscribed angle, and I'm not given my arc, and that's what I want to find. So let's say my inscribed angle was 50 degrees. Okay, I want to find this arc here. Let's call that x. So let's plug in what I know. So based on this formula, again, that we know, my angle, which in this case is 50, equals 1/2 my arc. My arc in this case is x. Okay, well, how do I get rid of that 1/2? Well, to get rid of a fraction, we multiply by the reciprocal. So I'm going to multiply this whole entire thing by 2 on both sides, right? What I do to one side, I have to do to the other. Well, 50 times 2 gives me 100. So x is 100 degrees. So instead of x here, I should have 100 degrees. Okay, those are an example of inscribed angles. That's part of what we learned for 11.5. Okay, I'm going to erase all this. Let's talk about what other things we learned in 11.5. So in 11.5, we also learned about inscribed figures. We talked about inscribed triangles and inscribed quadrilaterals. Okay, meaning that those figures are inside of my circle. So let's talk about inscribed triangles. Okay, so we talked specifically about right triangles, inscribed right triangles. Okay, well, let's note that my hypotenuse equals my diameter. And diameter, we know, goes from one end of the circle to the other, but has to go through that center. Okay, so there's my example of my diameter. Okay, so with a triangle, a right triangle, I'm going to draw in my right triangle. Okay, so this is a right triangle inscribed in my circle. Okay, well, let's say this part is 53. Oops. Solve for x and solve for y. Okay, well, in order to solve for them, I need to first figure out what angle is what. Because it's a right triangle, one of those angles has to be 90 degrees. Well, in this case, because my diameter is here, and it is across from my x, right? My y touches it, so that's not working. My 53 touches it, so that doesn't work. So x is the across angle, which means that that angle is 90 degrees. So x equals 90. Okay, in this case. Sometimes it could be y, it could be a, it could be r, t, okay? But I still have to find y. Okay, so if we remember way back when, in a triangle, all my angles add to be 180. So I have I have my three angles here, so I have x plus y plus 53 equals 180. Well, I know that x is 90, so I can replace that. Plus y equals 53 equals 180. When I combine my 90 and 53 and then subtract from 180, I should get y to be 37 degrees. I have my y, I have my x, and I am good to go. This is another part of what we learned in 11.5. Okay. So right triangles, again, those three angles add to be 180. One of them will be 90 because, again, it is a right triangle. My hypotenuse is always the diameter, so the angle that is across from that will be my 90 degrees. Okay, I'm going to erase all this. We're going to talk about some other stuff that we learned. So we also talked about quadrilaterals. So a quadrilateral we know to be a four-sided figure. Okay. A quadrilateral could be a rectangle. It could be a square. Could be some weird shape that as long as it's got four sides, then I'm good. Okay. Well, what I found about an inscribed quadrilateral was that opposite angles are supplementary. Supplementary meaning they add to be 180. Okay. So I'm going to draw an inscribed quadrilateral. No, it does not have to be a square or a rectangle, but this figure does have four sides. Okay. So it is a quadrilateral. Okay, so let's label some of these sides. I'm just going to randomly pick some numbers right now. We're going to solve for x and y. I'm going to label this as x and this one as y. Let's go with 105 degrees here. Let's go with 87 degrees here. Okay, so in a quadrilateral, I'm given that my opposite angles are supplementary. So if I look at 105, the opposite angle to 105 is x. Okay, so then I can say x plus 105 equals 180. My goal is to solve for those measures of x and y. Okay, let's talk about 87. The opposite angle to 87 is y. So I can add those two. Y plus 87 gives me 180. Okay, again, because opposite angles in a quadrilateral are supplementary. Supplementary meaning 180. Okay, well, I know how to solve for x and y. Subtract some stuff over, right? In the first one, I can subtract 105 from 180. I get x equals 75 degrees. Okay, so instead of this x here, I get 75 degrees. And then if I look at y plus 87 equals 180, subtract that 87 over, I should get y to be 93 degrees. So y here should be 93 degrees. Okay. And then if I wanted to double check, well, if I add all those four angles, so 87 plus 75 plus 93 plus 105, because this is a quadrilateral, quadrilaterals always equal 360. So if you wanted to check, add those four angles up together, set it equal to 160 and see if you get 360. See if you get 360 on both sides. In this case, I do, so I know I did my work correct. Okay. This was, again, a review of 11.5.